And welcome back to another episode of Solidity Fridays. It has been quite a while since our last one, but there's been a lot of developments in the space. Most recently, we had Paradigm CTF over the weekend. So I thought it would be a really cool idea to go over the 0xMonaco game that Transmissions 11 built. I have with me today Mr. William Schwab, as usual, and Tamara Ringas. Hi, guys.
Hello. Hi.
What's up?
I'm really excited to go through this one. I think it's such a cool game. I've heard people say that it's better than Crypto Zombies for learning Solidity.
Really?
But I feel like you really need to know Solidity to play it.
Wait, hang on. You guys see my, oh my gosh, my like bar just popped up. Okay, let me kill it. Nope, that's not how you do it.
North Korea has entered the chat.
You like hack into this now. Look, well, I can actually do like Unix commands. Okay, cool. We're back. Uh-oh.
Cool. That looks good.
Sweet. So, yes. Tamara, do you want to tell us about this post by Transmissions 11?
Sure. So it's a racing car game where they have a set zip that you download with their code, and then you have to submit something called a car. And there are 1,500 points, ELO points that you can get. And maybe later we'll get into the ELO math. And then you write a smart contract with your team, and in each race, there's 3 cars, and the best smart contract that beats the challenge wins. Yeah.
Sick. Yeah, I think that's how I understand it as well. The interesting part is the game theory that developed throughout the tournament, or throughout while it was live. Because, yeah, as you said, there's a few actions you can take, and we've got the rules here. Maybe I should just go through the Twitter post first. Yeah.
Yeah.
So,
cool.
all right. So, yeah, it's made by these lovely people, Paradigm, and even Dan Robinson. Cool. I mean, that's about the gist of the post. So Zero Age from OpenSea was the guy who had the winning car in the end. We can dig into that, but I think let's first go through the rules.
Yeah, cool. I think
Okay,
that's a good place to start.
so take us through it, Tamara.
Oh, cool. So it's an on-chain player versus player racing game designed to test your game theory and PvP chops. I love how young everyone at Paradigm is, and that they're so like, it's really fun. It's cool because they're really clever, but they're also so like fun. So yeah, each game involves 3 players, so it's essentially 3 teams. Each player is an immutable smart contract. We call these smart contracts cars. Your CTF team will submit bytecode for a car to compete on your behalf. Your car will be matched against other cars of similar skill in a number of rounds using the ELO rating system, which is quite an interesting set of math, the way they got that ELO rating system. And if we get a chance later, it could be cool to get into that. Cool. Matches will be conducted every couple of minutes or so and can take up to a minute to show on the UI. You can update your car's bytecode after each race as many times as you want in response to its performance. That's cool. At the end of the CTF, the top teams will be awarded a fraction of the 1,500 point prize pool based on the final ELO rating of their cars. And then, yeah, we can look at at how those ELO points work. Do you want to do that now, or do you want to finish with the rules first, Ben?
Let's just go through the rules. I guess then we can jump to ELO after that, if that's what we want to get into. So
Right.
here we go. Yeah, keep going.
Okay, so in a pseudo-random order, cars will be called on to take turns making moves on the race track. During their turn, a car is allocated 2 million gas to make any moves or decisions of its choice. There are two types of moves a car can make. They can accelerate, which increases the car's speed by however many units until that it is called with. After each car's turn, everyone's Y position will be increased by the car's speed. A car's speed never decreases except when it is hit with a shell. To fire a shell, shells allow a car to set the speed of the car in front of them down to 1. Shells can only hit the car in front of the car taking its turn. Shells instantly take effect. They do not act like projectiles. To make these moves, cars must purchase them with coins. Each car starts off the race with 115,000 coins. The price of moves is determined using unique mechanisms similar to GDAs. Is that
So that's gradual Dutch auctions, which
oh,
I've
cool.
got over
Okay,
here.
yes, yeah.
Yeah, we can definitely get into this.
Yeah, let's just finish going through all the rules and then let's look at the ELO and then the Dutch auctions. That's cool.
Yeah,
the price of acceleration is targeted to be 10 points if 2 accelerations were bought per turn. The price of firing a shell is targeted to be 200 coins if a shell was purchased every 5 turns. If moves are being bought faster than this rate, prices will increase exponentially. Yeah, that makes sense. And if moves are being bought slower than this rate, prices will decrease exponentially. The price of moves is global, meaning one player's purchase will also affect the pricing for everyone else. As a result, players can implement unique strategies like pricing, gouging up where they purchase moves. They don't need in hope of pricing other players out of purchasing them. And that's probably where all the game theory and game mechanics came into play here.
Exactly. Like, I mean, the cars I've seen, it all kind of like plays around manipulating pricing, but then also like, I saw one that was basically, it would like, regardless of what other people are doing in the race, it would just look at the pricing of shells and an acceleration and buy it when it estimated it was like underpriced. So it's like a value investor strategy. Yeah, so there's all sorts of like game theory around this stuff.
Yeah,
but awesome. Yeah, let's keep going.
At the start of their turn, cars will be given a list of all car data, Y position, balances, speed, etc., to make decisions on. Cars can also request the current price of different quantities of moves, which car will make their turn next, predict the future prices of moves under various circumstances, etc., by calling back to the Monaco contract, and that's that zip that you download. Cars can also request the current price of different quantities of moves, which car will make their turn next, predict the future prices of moves. Oh, sorry, I've read that. An example strategy might be to accelerate if the prices of accelerations is below a certain constant, and fire shells if there's a car in front going faster. Yeah. A more complex strategy might take advantage of the data that it has on other car balances to purchase shells to inflate the price if a car behind it can afford a shell. Yeah, that's clever. A Monaco game ends when a car reaches a Y position of 1,000 or greater. Make sure to conserve your coins. Cool, so then you can get that zip, which maybe we should download if you haven't been. And then should we look at the ELO and the gradual Dutch auction code?
Sure, yeah, so I've got the zip downloaded. Just tell me if you guys can see this. This is VS Code.
Yeah, we can see it.
There's Mr. William Schwab in the code, hacking away.
That's cool.
And so, okay, so like, where do we want to go from here, I guess? We've got the code, the system. Maybe that is like the starting point. Or there is, yeah, transmission 11's ELO to score logic.
Yeah, I don't think we have to go too in depth with the maths of it, but let's see how scores are calculated. Yeah.
Okay. So what's happening here? Teams who compete in 0xMonaco scored competitively using an ELO rating system.
Can you zoom in a bit, please?
Sure. Yeah. Sorry, I forgot about that. Is that better?
Some of us wear glasses. Yeah, that's perfect. Thank you.
Awesome. Once races conclude, we'll begin constructing a list of all the teams who are within 191 elo of the team with the highest elo. Okay. And then a max distance of 191 is chosen, as it roughly translates to the underdog having a 75% chance of winning versus a higher elo player. Okay, so this is, I haven't actually like properly dug into elo rating systems before. It looks pretty deep.
Yeah. Great chance to learn it though.
Yeah.
Such a cool application of it.
Do you want to take us through like a description of the system or on one of these pages, or should we go into the code? Where do you want to go from here?
It's up to you. Maybe a description would be cool, because it is kind of how the end scores are decided. So it's quite pivotal in the game.
Simple. Okay. Which one of these is better?
I think we do the multiplayer one because it's a 3-team game, well, 3-car game.
Okay. Okay, so I think you need to understand. Yeah, okay, so like this is the multiplayer system. At the end of a game, you make a list of all the players and sorted by performance, and that's like what Paradigm was doing. And then they just truncated the list at a point. So yeah, so they made a list of teams that were within 191 elo of the highest team. Okay, and then so given that list, then you think of the system as each player, they having played 2 games, they've won the game against the person below them, and they've lost the game against the person above them. And then you update their elo ratings according to that list. Is that how you understand it, Tamara?
Yeah, I think so. And then, each player to start has a random initial simple multiplayer elo of 1,000 or 1,500, which I think is what they also used in Monaco. Same value. Where do they say that?
So they had, what was it? 15,000. No, 1,500 exactly. So that system points up for grabs, right? In each race.
Okay.
Or is that
per team? I think it's in total per race.
Yeah, looks like it. Interesting. Okay, cool. All right,
Should we look at the GDA?
The what?
The gradual Dutch auctions, just to see how the pricing works.
Okay. Yeah,
and from there we could start digging into code.
Yeah. So I think the gradual Dutch auction. This is the basic one from April, and then they expanded on the gradual Dutch auction mechanism for the mechanism that they actually used in 0xMonaco, which is variable rate gradual Dutch auctions. And they just released this, I think, like 2 days ago. Yeah. But let's first understand gradual Dutch auctions, just get an intuition.
Yeah, cool.
So basically the system, gradual Dutch auctions were designed to facilitate efficient sales of assets that do not have liquid markets. So that could be some collection of like NFTs, or it could be fungible tokens as well, but like some batch of them, some large amount, and you're basically auctioning them off. I suppose then it's like you would want to understand what a Dutch auction is, and so if people aren't familiar with those, that Okay, I don't think the Wikipedia article is necessary here. Basically, what it is an auction that starts with a high price, and the price slowly declines over time. It just goes down over time, and that could be linearly or like on some other curve, but it's just assumed linearly until it's either hits like an end floor price, or someone decides to like bid at some point in time. So you can imagine like this auction hall, and there are like 10 people sitting in the auction hall, and you're kind of waiting for the first one of them to say like, okay, sick, I'm happy with this price, I will buy it. And so it starts super high, and then the price just goes down and down and down until the first person says like, sick, I'm buying it. And then that's the end of the auction, that person wins. So there's game theory around like, how far do you think the price will fall? Because you obviously want to not overpay for it or pay as little as possible, but you also you have to be the first person to bid if you want to win the auction.
Yeah, exactly.
Yeah. So that's a Dutch auction. So now Paradigm expanded on that with a gradual Dutch auction system, which where there was a really good explanation somewhere. Yeah, so let's say you have 10,000 NFTs, and I think I don't know if these ones. Okay, so in the variable rate gradual Dutch auction, that's a different mechanism, but in the normal gradual Dutch auction, this kind of is split into two variations. You get the discrete one for like non-fungible items, and that'll look like this sort of discrete graph, or you could have a continuous Dutch auction of like any sort of fractional fungible items, which looks like this continuous graph.
Okay, interesting. So with these moves, with the accelerator and the shell, do you think those are discrete, or do you think that's continuous?
I guess it's discrete, right? Because you can't get like a fraction of an acceleration.
Yeah, true.
Yeah.
And there's only so many of those moves available each turn.
Is there a limit on
how many
are available?
On the coins you have here.
Yeah. So okay, yeah. So that is the cap is the coins form
determining factor. Okay.
Limit. But so basically, what's happening here is that instead of selling all of these items, so like all the shells in a single Dutch auction, that's the price is going down, and you can at some point buy the whole batch of shells. You do it one at a time. So you start with like the first shell, and you do a Dutch auction with the first shell. Is that what they're saying here? Yeah. So essentially, the reasoning is that there may not be interest from buyers to buy all of them at a single point in time. So then you start doing them one at a time.
I think that's also basically better for gameplay. Like you don't want someone to buy all the accelerates and then everyone else is left behind.
Well, so this is, I mean, right now we're just building up the reasoning for how a GDA works. So this is just to form an intuition. So you, instead of like this big batch, you're starting to see it as one at a time. And then discrete GDAs are an extension of that. And then like due to their mathematical properties, which I don't know if we will get into because it's some pretty deep stuff, you can do that for any given amount in that quantity that you have to sell. So let's say 10,000 NFTs. Someone can come in and buy like 5 or 100 or 500, and it will calculate the price based on the quantity that they're buying.
Yes, okay, cool. That's very interesting.
And given time. Yeah, sweet. So I don't think we should get too far into that because it's like the math gets quite deep.
Could be another episode, actually. I see they have a Solidity implementation of it.
Yeah. So that's Frankie He likes to do the implementations, I think. Where are they? Yeah. Nice. We could do that one
Definitely
point.
gonna look at this weekend.
But let's get into Monaco. So here we have the repo. Can you see this fine? So zoom in a bit.
Yeah. I think I can see it fine, thanks.
Okay, cool.
What's signed what math?
So that would be their math library that they used. And in some Solidity math libraries, 1 WOD is like a kind of like a unit. You just means usually 1 with 18 decimals. So yeah, really just represents 1 with 18.
Okay.
Like a unit 1, but in the format of 18 decimals, and then you build these like math libraries around it, usually very gas efficient math libraries, to deal with that form factor, like 1E18.
Okay, awesome. Yeah, see, there's a lot of assembly, so
Yeah.
that must be very gas efficient stuff.
Yeah. Soulmates has 1 as well, which I've been using recently in just some projects. So yeah, can recommend that. I think it's fixed point mathlib in
Oh
Soulmates.
yes, that's a goodie.
Just actually interesting why they didn't use that here. Then maybe they found a way to do it more efficiently, or yeah, not sure. I mean, I see unsafe. That's probably not something you want in a DeFi protocol.
Yeah, fair enough.
Unless you're an unchecked boy. You can just wrap everything in unchecked. Okay. Cool. So where do you want to go from here? Do you want to like look at the cars, example cars?
Yeah,
or do you
either
wanna go-
I think the contract itself and then the example car, and then maybe we look at the winning car.
Okay, cool. Let's do that. Do you want to take us through this Monaco contract?
Yeah, cool. Cool. So yeah, those 3 authors from Paradigm, geniuses. Cool. So using Safecast library for Unit 256, rad. And then
Sorry. Just I guess like guide me where you want me to
Okay,
go.
cool. Should we look at some of the events to start with? Would you
Yeah,
mind closing the terminal, please?
Sure.
Thanks, man.
We don't need that.
Not yet, or not now, yeah. Okay, cool. So there's quite a few events. Turn completed, and it just returns all the data from the turn. Shelled, does that, I wonder if that's called when you get shelled or when you shell someone. Probably when you shell someone, I think. Car index, smoker, smoked. Okay, it gives information on both. Accelerated, registered, punished, rewarded, and dub. What is punished? Is that if you break a rule? I guess we'll see.
Hey yo. Turn car. Yeah, I'm not sure actually. It's an interesting question. It's not. Well, okay. So, I mean, it seems like it's not used here, but I think this would be inherited by the actual contract that they have running in their system to simulate
I see,
the game.
yeah.
So, yeah. Interesting.
They also have rewarded. Perhaps rewarded, you get more coins. All it says though is the index turn and the index car.
Yeah.
And then dub. I guess that's if someone wins.
Yeah, that's what I would.
Right.
Car index winner. So yeah, they get the dub.
Nice. Miscellaneous constants. It's interesting that they go for like a UN72 there. Players required equals 3.
I guess, does this pack? It is interesting.
Oh, I think so. Let's see if it packs.
60, no, I mean, it doesn't, this is its own slot.
Yeah, it would be.
This packs, is there anything about this? No.
No, just events.
I don't really know what's going on here. And it's also like, maybe it's like a UN72 bits, because where this constant is used in the calculations, or it doesn't, maybe it gets packed there, but it might also be that the other variables that it's used in the math are of this format.
Oh, I
see. And so you don't cast between them.
Oh,
maybe
yeah.
that
makes sense.
Yeah, because I mean, otherwise, like
UN72 and see if it's used later.
Yeah, it's I mean, I think what we're looking at here is also just like a very we're only looking at like part of the code of like the whole system, and a lot of the system was probably a bit like proprietary and running on some sort of server. Because I think that's like, if you go back here and look at the site, you say submit a car, you would like put in your team name and then the bytecode of the contract of your car. And I guess that just gets uploaded, and then they would run that race, or pair you up. I think at that point, actually, they work out your ELO, your estimated ELO of that car.
Oh, I see. So who you would compete against.
Yeah, and like then it's matchmaking, like a matchmaking system. So you would race your car against some like comparable car, and then so that would all happen on their servers, I guess. And I think
so there's a lot of code we're not seeing.
Yeah, exactly. But here we go. Okay, so it's just these two. Yeah, so I mean, here we see like timestamp, the block of timestamp getting cast to UN72, which is set to Entropy. Yeah, it's not super clear to me why we're using that, but I assume it's some like packing of variables, and then those variables are used in calculations with these ones. Where is it? Yeah.
Very cool.
So I mean, Entropy was a new one that we saw.
Yeah, right. Cool. And then there's post shell speed, which is always 1. You always get reduced to 1 speed after getting shelled. Starting balance, that's your coin starting balance. And finish distance is also a constant, that makes sense. Cool, then they have some pricing constants. I assume this is in gas and not in coins, although I don't know.
Shell target price, interesting. Maybe this is kind of like variables in the Dutch auction system, variable rate Dutch auction.
Oh, that could be, yeah.
I'm not sure, but so you have a target price. Actually, if we go back here, yeah, like I mean, a target price sort of indicates maybe a price ceiling, and then this is the rate of decay, I think. So shell per turn decrease. So this is like how much the price decays over time.
And they said it's actually exponential decay, so that must ensure an exponential decay, that constant. Yeah,
well, I mean, right now it's just a constant, but like I guess we're going to be plugging these into the system at some point. Yeah.
Okay, cool. And then they have these 3 things for the shells, and then for the accelerators.
Yeah. Cool. So I think this all forms that like just sort of the inputs for that variable rate gradual Dutch auction for these 2 items.
Yeah, that makes sense.
for
to me.
accelerate and shell.
Okay,
Yeah.
cool.
And then we have an
Cool.
enum for game state, waiting, active, and done. And there's our state, I suppose, which is just one global variable, which is this enum, waiting, active, done. There is this entropy thing. Okay, so let's not skip ahead. We have turns as well. And then I guess that it just increments until someone wins, I assume. And then we have entropy. This is random data used to choose next turn. What do you think that is?
Should we go to where it's first called, or like defined? Because I see they have entropy and then they make a new entropy later for the next turn.
So
this
here,
is
if total
in
cost
setup.
equals players required, yeah, in register. So at this point, basically as you would call register to register a car, or their system's calling it, and once it hits the 3 cars, then this will say total cars equals players required, and then it will calculate entropy, which takes basically time, the timestamp at that point.
That, yeah, to unit 72.
Yeah, but I don't think, I mean, that's enough to store the like the Unix timestamp these days.
Yeah,
so you're not,
You're not really, okay, I see. And then they set the game to active. Okay, so the entropy, I guess, they did say that turns are decided in a pseudo-random order. So maybe this entropy is just determining that pseudo-random order.
Okay, so here, I mean, now we could probably dive into the actual logic. So we have this, well, okay, let's I'm always getting ahead of myself. Let's go back.
Which is such exciting code. It's hard.
So much delicious code to dive into. So you have the current car. This is probably just the car making the move. It's interesting that it's I guess it is a turn-based system, right? Where you take turns to, each card has its turn, and in that turn it will run that car's logic and calculate its actions. And then once that's done, it will increment the turn and then go into the next car. And so we do that with this sort of global current car that'll be loaded car and taking the turn.
There's an interesting point by William in the chat saying, what's random about timestamp unless uint72 doesn't store the whole thing, but it should.
Exactly.
I think it will. So that's very interesting. Maybe later when they calculate new entropy, they take the old entropy and do something to it. But then they could have just taken the timestamp at the start and done something to it.
There we go. Yeah. So.
Oh, I see. And then they hash that.
Exactly. So I mean, Will's definitely right in saying that timestamp. There's nothing random. Well, not that random about like taking this arbitrary like timestamp and then just like storing it in uint72. Like maybe if you were truncating it somehow, like by forcing it into a smaller uint that wouldn't hold the full value.
Like a uint8. Or...
Yeah. But I think the idea is it's.
Yeah, but they're hashing it there. I hadn't seen the hashing it. I just saw them it before. It's interesting that they take it as a uint without hashing it, though. Doesn't that just make them another? Wouldn't that make them another mload? Because they're stored in memory as the uint72, but then they need to mload it to hash it again.
Yeah, they could have just done it there.
They need to cast into 256 even. Oh, I think casting the uint256 should be free. Oh no, but they're casting the bytes 32. Sorry, Ketchup gives them a byte 32 on it, and then they're putting that into 256, and then they're re-uint72ing it to slice it back down.
Yeah, but I think this is like really where the randomness comes in, is we hash it.
Yeah, for sure.
Turn. Yeah, and we get new entropy. Yay. Okay, so this is our like random
based on
factor
that
in the
new
system.
entropy, it'll choose who goes first, and then in the next turn, it's not like a fixed order of turns taken in each move, or like, so each car might go in a different order in each turn. That's my understanding of it because of the new entropy.
Yeah, that's a good point. That's an interesting mechanic, that it's not always the same like order of moves.
Yeah, because if someone's always first, maybe they have an unfair advantage.
Exactly.
Cool.
Or you could build weird strategies around it.
Yeah, you could build very weird strategies around it, and people definitely would.
Cool. Right. So let's just finish up here. We have card data, okay, which we didn't get to. Or we have actions as well. Accelerate. These are just sold. So this is, I guess, is a mapping from like the accelerate and the shells, these two types that we have here as the key, to a uint, which represents the amount sold. So tracking how many accelerates have been sold and how many shells have been sold. It's interesting. I don't see this too often, a mapping that uses an enum type as a key, but it is. It looks like a.
But it's actually quite a nice way to do it. Yeah.
Yeah, I quite like that. Sweet. So then we have car data. This is the balance. I think this is the money. And you start with, what is it, 15,000?
Yeah, it is 15,000.
I think it's in the rules. Yeah. 15,000. Yeah. Oh, and I just saw now. So that 1,500 of in the ELO pool, or the points, that isn't per race. That's in like the whole system.
I see.
So at the end, depending on the ELO rankings, that's how they split up the pot. Sweet. Yeah. So Carl, we have that. That's the money balance, their current speed, and then their Y in the game. So this is like a 1D racer game. There's only one dimension. You can only like move forward really in one dimension, and that's this Y value. So it starts at 0 and it increments over time until it's at 1,000, I think, is the end, just based on if you look at these, you just choose like a random race. If it will load. Sick. Can you see everything? Play. Whoa. Chill, bro. I think we chose the wrong race. It doesn't look like these two guys doing too well here. But yeah, I think
that's
like
one of the strategies, though. I think a lot of the strategies involve people even hanging out close to the finish line for a while. Galwal had a whole thread about doing it. I don't know if he actually did in the end.
Then they eventually shell them and bring them back. Because maybe then let's say in this race, 2 people aren't going, but Gaussian process is. They could waste all their money accelerating, and then you shell them back to 1. And then now they don't have much money, and then they can't shell you, and then you can accelerate after you've shelled them back to 1.
Maybe jump ahead to like 975 or so.
Right. Sorry, I thought this was out of 100. Okay, let's go a bit faster here. Stop. Okay, so he's there. He's getting there. 900, 975.
You're still on 16 a second.
Sorry?
You're still displaying 16 turns a second.
Yeah, but it's paused. It would be, so I play it now.
Got it, sorry.
You can see he's oscillating, I guess, between these 2 points in the game. That's super interesting. I didn't know you would
they didn't actually
fall back.
him.
And they also, I think these cars,
I would think they would have to shell him if he's back, because is there any other way to lose him other than being shelled? It could be that I wasn't paying too much attention during the acceleration mechanics, but if he's built up enough speed, is there any way that he's getting shelled but recouping that much distance?
I don't think you could do that in 1 turn. I think it's because we're toggling between 2 turns. So there, oh, I see, maybe. Because I know shelling brings you back to 1.
So, yeah, I don't know what's going on here. If it's because these guys still have all their coins. They haven't spent anything on shells. This guy only has a speed of 1, and it looks like he's just spent on that 1 speed.
We need to do better.
So yeah, maybe we did choose a bad game.
Yeah. Anyway.
But yeah, it would be fun to watch some of the games later.
Yeah, I think, is this...
Oh, this is about that exploit.
That's the exploit. I have this thread. I wonder if they have the actual like winning for some of their games. Let's see. 0x's one.
If you go to teams and elos under just on home, on their homepage.
Here we go. This might be, yeah, but like we can take a look at that. But this is the, I think this is one of 0x's races. Wait, he just said something about it. Yeah, okay. So here, this is one of them. So the OpenSea one is probably the one that won. So this guy's doing super well. Okay. And I guess we were just sort of, we got to this point by asking the question, like, how long is the race? And it does, yeah, it's 1,000. But here, it only got up to turn 75, so I guess they ended the race before that. And you can see here he comes from the back with this, like, insane acceleration and then overtakes.
Oh,
which
so cool.
I think it was the strategy that he went with this car.
Maybe it ended early because all players' balances reached 0. I didn't watch the coins there too well.
No,
Oh, no,
I think
yeah.
it's because
Oh,
he reached the end.
He reached the end. I see.
Yeah, yeah. And he had like a lot of, so I guess he was like conserving money. And both of these guys were probably shelling each other and accelerating. So they're like down quite a lot. And then he just starts spending money on acceleration and like slingshots at the end. Cool. So where were we? Right. I mean, that's,
We're about to get to setup now after car storage.
yeah. So we did kind of go through this register. You're registering a car. Okay, so it's just checking. This is interesting. I guess they, in their system, they are like, yeah, deploying the car contract, so it has an address. Yeah. So it has to have actually been deployed. It's not the 0 address, otherwise we'd be registering it multiple times. And then it just sets its register.
Yeah, it just
Quarter
sets
as a
its
car
data
is
to the
RS.
starting data
Yeah.
for all cars.
Yeah.
And then it
nice.
pushes it to the list of cars.
Yep.
Of which there should be 3 in total at the end. So this will be the first car maybe, so it's index 0.
Yeah.
Okay, so then
And
they
then-
check the length of the cars, yeah? And then they're saying if that length equals players required. So now if once we have 3, we get the block timestamp. It's entropy, but it's not random yet. Set the state to active. Otherwise, wait until we have enough players. And then emit registered 0 and car. What is 0? Can we maybe look
That's
at that
probably
a bit? Or maybe the turn.
The turn, yeah. So like, okay,
Cool.
so yeah,
Cool.
so 0, they register their, where is it? Back down here. Yeah, so for all of the cars, they registered on the 0, it's turn, so the game hasn't started yet.
Yeah, nice. Okay, cool. So now we've set up, let's say we have 3 cars. Should we look at the core game?
Let's do it. Take us through it.
Right. Play function. It has a modifier on it only during active game. I don't know if you want to jump down to that modifier, or if you want to.
Yeah, so just active, yeah.
Oh, okay, cool.
Gosh. Back.
Oh,
There we
thank
go,
you.
let's play.
Cool. All unchecked. And it takes in turns to play. And this is external, so obviously your contract will call play.
Well, I think their system calls play. So you just submit your cars as
and then it plays them. And
Yeah.
it probably chooses who calls play in what order based on that entropy, the new entropy. That's that hashed value that chooses that pseudo-random order.
Yeah, that we will get to that. That's the current. Yeah, so that just shuffles the cars. Essentially, this entropy just uses a Knuth shuffle, which is a nice shuffling algorithm, and then just shuffles the car order. That's essentially what's going on here. Yeah, it's interesting to see like the turns to play, that argument being passed in. That might be maybe for like gas management. So you might not want to. You might only want to like play one turn, or you could like simulate 10 turns or whatever. Yeah, but obviously, like simulating 10 turns might be gas costly.
Mm-hmm. Okay, cool. Then there's a loop. So we have turns to play, and as long as turns to play is not equal to 0, we decrement turns to play. Then we get and cache the cars in that car array. Current turn equals turns, cool. So so turns started at 0 for everyone, but then that'll probably increment later down, further down. Okay, then we get the current car by moduloing the turns variable by the player count. So let's see what they do there. Oh, I see. So they select the car based on that remainder from the division of current turn and players required. Then they get all car data and the current turn car's index, so we can pass it via take your turn. I guess we'll see take your turn soon.
Here's take your turn. So current car, that was that global variable. And we're just getting that to the current turn car. Get all car data and final car. So we're passing in the current turn car. It's also setting it to the current car to be dealt with. But then, here it's just pulling out the car data. And then its index. Let's see, is that in the array or is that like your place in the?
It's probably a bit of most of it. So it returns results and found car index.
That looks like it's actually the index in the array.
Yeah, it must be. Okay, cool.
Yeah. Sweet. Okay, so we'll be doing something with that, car index.
Cool. So then they set that car to the current turn car, and then they.
I see. So this is interesting. So I was wondering why do we care about the index? So in your car, you have take your turn, and that's so interesting. You pass in all the cars, and you get your index in like where your turn is in that round. Wait, is it all the cars? It is all the cars. Wow. That's a lot of data. So like your strategy, you can literally like read the data. I guess in the data, it's not reporting a lot of stuff. It's just reporting this, like each other car's balance, their speed, their wide position.
Still, that's like quite a fair amount when you have 3 cars. I guess there's only 2 other cars you're really looking at, so that's only like 8.
So you get to know that,
Yes.
and then you get to know where you are in that turn ordering.
Okay, that's quite cool. So you can actually see where other people are, so that you can say, if someone's in front of me by this X amount, let's shell them. Otherwise, let's accelerate.
Yeah. And you can use your turn order as well in your strategy if that's important to you.
Yeah,
to
which
get
I think for
like
some
that.
people it would be.
Yeah. Cool. And then interestingly, each car only has 2 million gas to run this take your turn function. So there is like an incentive to be gas efficient if you want to do a complex strategy.
Yeah, which is awesome. It's a really cool challenge, this. Okay, and then they delete the current car and restore the car to the 0 address. As opposed to removing it from...
This is just
like
the global
Yes,
car,
yeah.
which is this one at the top.
Okay, cool.
Right.
That makes
Yeah.
sense. Cool.
Um,
And then there's another loop. Okay, this just updates the data now for all the cars. Cool. So for I equals 0 and I less than players required I increments, then you just go through those 3, 0, 1, and 2 indexes and get the cars. And for each car that you get a pointer to that car's data struct in storage. Interesting. And then if the car is now past the finish line, then you exit early by calling return early. You set state to done, and you emit the dub event, which dubs that car as the winner. Otherwise, if it's the last turn in the batch, then I see you do another Knuth shuffle and get the new ordering for the next round on line 174.
Yeah, it's interesting. So, because, okay, so where does this for loop end? Yeah. So do you do a shuffle like every time someone takes a turn? So, like, it doesn't
No,
seem
I don't think so.
like,
You do a shuffle only at the end of a batch of turns. So if you go down a bit to like 170-ish, so it's only if it's the last turn in the batch, and you get that by doing the modulo. And if the remainder
I
is zero,
see. Yes.
then you
you're correct.
only
I
then
didn't
you
see this.
shuffle. Because yeah, otherwise you could shuffle and shuffle and shuffle, and one player could always be the one going.
Yeah, I was thinking that would not be a very fair system, but yeah, this only happens at the end. So yeah, everyone gets their turn.
Yeah, cool. And then they just set the new entropy, which we've seen how they do. They hash that entropy
Yeah.
timestamp.
Exactly.
Cool. And then that's just them doing the Knuth shuffle, which is, yeah, really fun. Cool. Then you reorder cars using the new shuffled ones.
Cool. Yep. And then we just get a turn completed. Sorry.
They say if we were to deploy this on chain, it's in this line, it would be pretty wasteful gas wise. I like that they're teaching people through this challenge. It's really cool.
Yeah.
But I wonder why it would be wasteful gas wise as opposed to if they reordered it. But maybe we don't have to get into that right now.
Well, okay, so it's like if we look at some of these things, get acceleration cost. Jeez, okay. This is probably why. Yeah, so amount. It's also like maybe you could compute these prices together instead of calling these loops kind of sequentially here.
Yes, that makes sense. Awesome. Cool. Then we have our actions next. So it'll probably just be the acceleration and shell actions.
Yeah, by acceleration, by shell. And I guess in these you would need to get the cost of each one, which is then going into the whole auction system.
Yeah.
Is there anything else you want to cover here, Tamara? We have 2
Just
minutes
go
to
down
1 minute left.
after this. Is it just the buy shell and then the well, buy shell is quite expensive, or kind of like a hefty function. And then after that, it's just the modifiers here.
Well, you have
Oh,
these
it's
new
the
functions,
which we actually looked at when we were emitting that event. We briefly looked at these now. Cool.
Yeah, I mean, that's pretty much the system. We could probably dive into a lot more.
Yeah, we also haven't looked at the car yet. I'm we didn't get to that, but it's good that we went through this so in depth, because now we really understand the challenge. It's such an interesting one, really cool.
Yeah. Yeah, so that has been 0xMonaco. Let us know if you want to see a version 2 where we take a look at some of the game theory or some of these Dutch auction mechanisms used in the system.
Because we could also look at the cars and the exploit that was patched.
Yeah, we didn't even take a look at the exploit. That would be interesting as well. That's Mr. Brock Elmore found an exploit.
Yeah, part 2 would be awesome, maybe.
Yeah.
Right. Thanks, Ben. Thanks, Will. This has been really interesting.
Thanks, guys. Until next time.